Now we'll also have equations that are logarithmic that we want to solve as well. So let's look how we can solve a logarithmic equation. And to do so, it's probably easier to transition it to exponential world. So how do we do that? Well, let's remember how to convert a logarithm to an exponent. So let's rewrite this one in exponential world and see if it's a little bit easier to solve. So this rewrites as, remember, this is the exponent that turns a 4 into an x plus 3. So 4 squared equals x plus 3. Already now that looks a little bit easier to solve. 16 equals x plus 3. Subtract 3 from both sides. X equals 13. So fairly straightforward if we can get comfortable going back and forth between logarithm world and exponent world. Let's look at another example. 3 natural log of 2x equals 12. We want to try to isolate the variable term, so let's divide both sides by 3. From there, we can rewrite it as an exponent. Remember what the base is of a natural log? In that particular case, it was an e. So it becomes e to the 4 equals a 2x. And how do we isolate the variable? Divide both sides by 2. So it's e to the 4th divided by 2 equals x. And that's my exact answer. I can evaluate it too with an approximation by going to my calculator and taking e to the 4th, then dividing by 2 and get an approximation. So just a couple examples that sometimes to go from a logarithm, we need to go to an exponent in order to solve it.